Welcome to a new test and teardown video. This time it's a signal generator, sweep function, sine wave and everything. So it's from Exact and the model is 126. This one is very complicated. It got so many different features, and as far as I can read, it's all analog. It consists of all sorts of special features in the design, where it's converting the oscillator into ramps, and it's doing all sorts of things. It's really special. And the sweeps, it can be triggered by external events, or manually, or just run. So it's so this will be all the different ramps, and we can say all the different timings, variable timings and all that. And as far as I think, ramp and the normal output is, you're possibly able to do this at the same time, right? So that is very interesting. Definitely going to check that out. We got also a synchronization output of the main frequency, and it can even be voltage controlled frequency input. So it's just full of features, and the range is all the way from 1 Hertz to 3 megahertz. So it's very impressive. However, I need to open this before I power it up, because I see only 2 screws in the top lid. 4 screws are missing. This reveals to me that somebody was poking around in this. They gave up, gave it 2 screws, put it on a shelf, and now 20 years later it shows up in my shack. So, oh, look at that. This is it definitely. Ooh, this is broken. I need to fix that. But this is HP style fuse. Great. Mains selector. Backside is made of aluminium. And oh, you can do a ground lift from chassis. Power supply, regulators, and here is the model 126. I'm sorry, this is upside down. Oh dear. But let's fix this. What it says here is 1/4 of an amp. Okay, we're gonna do that, and then we're gonna open it. So now we're inside, and this is exactly what I imagined. Very complicated unit. Also, when I'm looking at the different components, 70. So this is a good indication of the age. And I guess this one is also 70. Where did I see, and this one is also 70. I also saw a, and that one, see, 70. It just goes on and on and on. Oh, see, 69. So this is the oldest component I've seen so far. So that means this thing is from 69. Everything in here looks very much like an HP product, really. They're using the same components, they're using the same kind of design style. The way that stuff is mounted, the same kind of quality, all those components, even all those, see, everything is exactly the same as HP are using. All this is the same. Oh yeah, I've been looking a little bit on the different capacitors in here. Look at this white stuff here. Oh, that can't be good, see? It is possible to get this off. I don't know what that is. You can see it here, and I've tried to clean it a little bit off here with a cotton bud, and it actually wipes off quite easily. This one didn't go off that easy. So we got a positive and a negative 12 volt supply. That is going to be the first things that I'm going to measure. and see if that is accurate. Got all the different sine waves and stuff like that. See, it says even here on the sine B, sine D, sine A, sine amp, sine DC. I really love when they write on the pots what they're doing. That makes it possible to fix this if it's not working. I really hope this is going to work. Oh, by the way, see the rectifier? This is not the original one. It looks like it was replaced. And let's look at the bottom side. There's probably a good explanation. So this is the bottom side of this single layer PCB. It's looking like a really good quality layout. And again, everything looks like HP in the 60s and 70s. This is totally the same design style and the same way that they're doing everything here. I even think it's the same font. Look at that. The same way. Well, this is definitely something. Where did I find? Yeah, here I found it. See? 4/10/70. So this design by JLS 70. And then the logo and everything. So this was the rectifier repair. So I think I'm going to power this up now and see if it blows the fuses. So let's do this. I put 2 channels on my scope so we can have a look what is going on. I probably want to attenuate the output. Let's just go for 1 kilohertz. Let's dial this down to milliseconds and 220. Oh, we got output. 22 watts, 19. Okay, 19 watt. Look at that. Hello. We got output. Oh, and this is, yeah. Sine, yay, yay, yay. And variable. That is good. So how is the rampy thingy here doing? Okay, we got some. I don't know what we got here. We got nothing. Let's look at that. We on this channel. Dibby. Oh, okay. So that is what it is. We got some pulses and stuff. Yeah, okay. I got it. So, and if I turn this off? No. Okay, doing what are you doing? Okay. That is what it does. So that. Okay. This one is definitely. So the ramp output is some funny, funky 3 running kind of stuff, more or less the same frequency, but it's looking like it's what exactly is it doing? Ooh, that was funny. So 1-way trick. No. Okay. We definitely got 2 different frequencies here. So 3. I got no clue what that is doing. Okay. It's not looking perfectly right, this rampy thingy, but it's definitely also very much full of noise, this pot. So this is the, okay. So that was this sweep. This is, okay, fine. So this is the multiplier. Doobie doobie doobie. Variable. What? Not. Okay. All that seems to be fantastic as well. So we got two different generators with DC and all that kind of stuff. And this one can do trick and whatnot. I don't know. You can probably lock these two together, or could be cool to. Maybe I should read the goddamn manual before I play absolutely stupid. So, okay. But I'm not using any voltage controlling inputs, la 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 la, so. But yeah, I think it works. So far, so good. How about we check? So this is 1 hertz. And let's turn off this channel. Let's see if it's doing a 1 hertz signal. And are we doing? Yes, we are. So now we got 1 second per division. So you can imagine this is going to take a little while before the curve is going to be there. Isn't that just amazing? And if this is the multiplier, where's here it is, 0.1. Okay, so this is how it works. And then 1.0. Ooh, look at that. So yes, you need patience to play with stuff at the lowest frequency. And see, we got 1 hertz per division. So I'm running a little bit over 1 hertz at the moment. So if we want to go, okay, this is not for my patience, isn't it? Let's just crank it up a little bit. So this is 10 hertz, 100. We want to do this at 100, right? So we get a little more live. Yeah, come on, baby. So that is a 109. Okay, so the frequency here is not super. Oh, so it goes in clickety clickety. So if I go, then it is 9, 1. I don't. What did I do? No, it's a 100. So that means there are some bad bananas in this one, right? Because all I did was poke around with this. Oh, the more I touch it, the more accurate it gets. So if this is accurate, now let's go to 1 kilohertz. And I didn't touch this thing. Doing. Aha! Wow, that is actually amazing. 10. It's also a little bit, tiny bit low. So how about I trim this? I can just slow-mo trim this for 10. So now this is 10, yeah? And it's about here, right? So if this is 10, then this is going to be 100. Oops. And then it's a little bit low again. But well, we are talking about 1%. So, okay, frequency-wise, this works. Triangle, square wave. Wow, square wave at 100 kilohertz. Sine wave again. So what is the difference? Ooh, inverted sine wave. Ooh, clearly. And then another triangle, and then this again. Okay, beautiful. Trigon, polarity, la 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 la. So this is the rampy thingy. Not much to say, really. Of course we can gate this and do some fantastic things. So now it is run, gate, and then I adjust the trigger, and then I can put in some sync, and then boing, 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 it's gonna put out the signal, right? See? Trickety, trickety, trick. Ah, now it's done. Now it's sweet, probably by this one, right? Haha. Ooh, that is something. Yes, 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 it goes faster, and then it... We're learning today. Aren't you impressed? So just in case you want to measure the voltages, there is a test point down here that says plus 12 volts. So let's try and... Oops. Come on, man. So that is 12 volts, and it is this trimmer to adjust for plus 12 volts. I don't really see a minus 12 volt test point. At least they hit it somewhere where it's not so easy to find, but of course this transistor here is the negative, and all we have to do is measure on the emitter. So this is pretty close to 12 volt, and that is again the circuit that is doing that, and you can adjust it on this trimmer here, and that is basically what I figured out so far. Since everything works, I'm not going to poke around with a lot of stuff. So all those power transistors, that is of course the output power drivers. But yes, really a beautiful circuit from 1970. What have we got here? Yeah. I think there's not much fun to do with this one. Since it just works so beautifully. So this is how we change all the different curves, and it goes directly down to all the different... Is that really it? What? So we got all those different ranges and only... Okay, yeah, I saw them. So the fastest is a trimmer capacitor, and then we go into film capacitors. Isn't that amazing? So I bet if I go to 3 megahertz, I could probably... Yeah, let's try and do that. So now we're at 3 megahertz. We have to dial this. Okay, we have to turn this sweepity sweep off. We're now in run mode. Oops, it is super accurate. How about we go with the multiplier back to 1.0. It is 5% off, as far as I can see. Yeah, okay, 305. So that is only 1.5% or something like that. So I don't dare to touch this. There's no need. But it is a little bit frustrating if this is accurate and then I go to 1 meter. Okay, damn it. It just gets better and better, right? So this is 1%. And then, yeah, again, 1%. Maybe there was a warm-up kind of time. So this is the 10 kilohertz, and it just gets more and more accurate. Or is this a... So this is the 1 kilohertz. Look how accurate that is. So let's go to sine. This has to be exactly the same, right? 107. So let's go to this. It got to be the same time base for everything. So, yeah, now it got a little bit of a warm-up, and now it's super accurate. Oh, maybe it's just because I've been poking around with this. That is sometimes what happens. But it really works. Super good. I'm happy about that. The last little trick I need to show you guys. Save all the screws from stuff you poke to pieces. So this is just like one of 10 of my inchy screws from all sorts of stuff. I think most of the screws here they'll be from HP equipment. So look at that. That'll be the original screws from this unit, and we had some in the bottom and we had some in the top. Now I can combine them. So we got all the 6 screws for the top, and then I just find 6 completely identical screws in my boxes, and now I can fix the bottom. Haha, it is that easy.